Now you see I did it a bit faster. I changed now all the dimensions. If we go slightly to our sketch geometry, here for example at the entry of the sketch I changed this dimension here, H3, and I changed H3 to 0.0762 meters. And please check it also in the sketch of your exercise. And for example, I changed also H4 to 0.0381, and you can refer to it in the sketch of the measurement. Also all the other dimensions I changed them. You see now the geometry is finished and the dimensions are the same as here in this exercise manual. Okay, looks pretty good. I've done this a bit faster, and now I go back to modeling, and the extrude is still, I suppressed it to do the dimensions in a better way. Now I unsuppress the dimensions, I underpress inlet, underpress outlet, and now it's more easy to see. Okay, go to inlet, check it, go to outlet, check it. The dimensions are okay now. Press again generate. It's never wrong to press it from time to time. And now just close your file. From while to while save it. Please always use the save button in the workbench, not in the single programs here. Now your mesh can be generated automatically. I update it. I just go to update. It will be done in the background. It will be updated in the background. Take your time. Wait. Don't click too much now on the screen. It will not help you. Just wait a bit. It will take some seconds because there's a lot of data points have to be calculated and saved. Now the mesh is finished. Same with setup. I could edit it, but I don't want to do it because I changed nothing in the geometry. I just changed the dimensions a bit, and now I update. I update the setup. Just wait. No problem. It takes a bit until the new dimension is finished. So here's a green tick. Perfect. And now I can start the simulation. But because I changed the geometry, I changed the mesh automatically, I don't want to keep the old solutions. I clear the data, go back to solutions, I go to update, and meanwhile I can display the monitors. I can check if the simulation is running properly. And yeah, although here it takes a while, it's a big model, you need some time for the simulation. And now the simulation is running. You see the graph for the residuals, the green and the yellow and the blue line are for the Navier-Stokes equations, for the solution of the momentum equations, and the red line goes also down to the residual and This is a mass balance. Take some times. And now, after our residual criteria is finished, the simulation is completed. All the residuals are below 10 exponent minus 4. Now I can close the simulation. I see the green ticks. And again, I can edit my results. Here the same, if you go to edit, don't click too much. Just wait, take your time, and then you see the new geometry with the new numerical results, and it looks pretty cool. Here is your plane. You can make it big, zoom in a bit. Yeah, and here you can see, okay, let's say the detachment of the fluid flow happens after 0.4 meters. And now if we divide zeros approximately 0.3 by 50 centimeters, we get about value of 6.6, and this fits really good to the results from the literature. And the backward facing step is a really well-known example for simulation. Many people have solved it before. It's a kind of benchmark for CFD, and you will find a lot about this in literature. Here's a good paper from 1984 from Vogel and Eaton, and they made measurements with this example simulation.